Hi, I'm Craig Ecclestone. I'm the PASCO product specialist here at AVA. And today I've got something very interesting to show you. It's one of my favorite demonstrations, particularly with the smart card. For those who aren't familiar with the smart card, I'll just brief introduction. The smart card is it is a wireless smart card, and cards have been around for years, but the beauty about the smart card, it's got sensors built into it. So I've got a little force sensor here at the front. That I've got a hook attached to it. I can detach that. I can put a magnetic bumper or rubber stopper. We have other accessories that can go there. We also have a positioner, an optical encoder in there as well. So under this wheel well that's right there, there's a little optical encoder that detects the position of this wheel within 0.2 of a millimeter. So it's very, very precise. There's a couple other sensors in it as well. One's an accelerometer. 3-axis accelerometer, so it can tell you the acceleration in all 3 axes, and a gyroscope for doing angular velocity experiments. Note when it's rotating like this or rotating like this. We're not going to touch upon that. Uses for the smart card, but there are, believe it or not, uses for the gyroscope. What we want to do here is we want to use 2 of those sensors, the force sensor and the built-in accelerometer. Why? Because I want to know what that mass of that card is. Now I could just look it up and see what the specs are for the card if I wanted to, but instead of doing that, can I use perhaps Newtonian laws and one of his equations, particularly his second law, force equals mass times acceleration, to determine what the mass of this card is, because I know that I've got force here, right? If I pulled on that right there, I would detect the force. I'll be pulling and pushing and pulling. And I'm going to simultaneously be measuring the acceleration of the card using the built-in accelerometer. So if I plot those against one another, I'll have a slope of some kind, and that slope should presumably equal the mass of the card. So this is how easy it is to set this up. So all I need to do is go under Build New Experiment, and I'm going to pick the top one here because I want a nice big graph. All right, and I get a variety of different functions or displays I can put into this window. And I'm going to simply take the first one, the default one right there, and it's going to be a graph. It's got time on the x-axis, and it just says select measurement on the y-axis. So the first thing I'm going to do is I'm going to select a measurement. So on the y-axis, I want to plot force on the y-axis. So I'm going to click there, and now I've got force on my y-axis. Now, what am I going to put here on the x-axis? Now, I know it's a little bit hard to see the screen, but I've got time there. So I'm going to click on time, and I don't have to leave it at time. I can change it to whatever I want. And if I go down this list, I'll notice a variety of different sensors and derive data from those sensors. One of the first sensors here is the smart card position sensor, and I could derive acceleration from that position data. But I'm not going to use that. I'm going to measure acceleration directly using the acceleration in the x-axis sensor that's built in. All right, so I've got force and I've got acceleration. Now, one of the first things I want to do is I want to zero it. That's hard, probably again, for you to see that on the screen here, but I've got force, it says minus 0.16. I want to zero that. That's simple enough to do. So I go here and I click on that and I hit zero sensor now. And I hit there. Okay, and now I hit the start button. And I'm now plotting the data. So I go and I push and I pull and I push and I pull and I push and I pull and I push. And you can see a nice, beautiful graph appearing. I hit stop. All right, so there I've got it. Force against acceleration. How am I going to find that slope? Well, it's actually pretty simple, because right on the tool palette, we offer there what's called a linear plot. We have all kinds of different plots, but obviously that looks like a linear line. So I'm going to click on that icon, this one right here, and it's going to give me a plot. And it gives me a plot of 0.242. You're just going to have to an end value. It gives me the slope of that line. And you're going to have to believe me that it says 0.42, because I know you probably can't see it on the screen. 0.42. Well, if I convert that to kilograms, How does that equate to the weight of the cart? Well, I think it's pretty close because as I recall, the cart weighs, they vary a little bit from cart to cart. They weigh around 450, 445 grams. So it's pretty close. Now, you're going to take my word for it. How can we prove this? Is there any way that we can show that this is an accurate method of measuring the mass of the cart? Well, fortunately, I have some weights here. Some masses, I should say, that are exactly 250 grams. So if I put those masses in the cart's tray, if I put one of them in there, well, now I've virtually doubled the weight or the mass of the cart. So I should probably get something near, 0.5, probably maybe a little bit lower because this is 0.42. So I guess if it was going to, if that had, was 100% accurate, then I would expect something to be about 0.492, just adding 250 grams. All right, so I hit start. All right, and I go. There we have it. Right there, I think you can tell that's steeper than before. So I go there and I hit stop. All right, I can bring back the old one. There, you got that one there as well. All right, so now let's see what that slope is. And I click on the linear line here, and it says 0.506. So that's pretty darn close to what my expected value is. I said somewhere around 0.5 or 0.506. So that's pretty close. And if I take another 250 gram mass and put that there, then I should get something obviously closer to 750 grams. And I hit start. And there we go. Pull and I push and I pull and I push and I pull and I push and I pull and I push. Let's see what my readings are. Hit stop. There we go. And my goodness, it's 0.774. So pretty good way, pretty accurate way of measuring mass, just applying Newtonian law. And I think for me, this is one of those experiments where, really, I think a lot of times we take things in faith when it comes to equations and how in physics and how, mathematics can describe the world that's around us. But I think that's pretty impressive. I don't think Newton had a smart cart back 300 years ago. I know PASCO wasn't in business. So, this very smart person was able to determine that equation. And here we are, 300 years later, applying it to weigh the mass of a cart, which I think, to me, if it doesn't give you a little bit of chill, I don't know what will in physics, because that to me is quite amazing. So, yeah, thank you very much.